Hey guys, so for the last 4 weeks, they want us to shove some knowledge into you. We're going to start with something fun, the reciprocal mother function. So we've dealt with mother functions a lot, uh, the basic points, transforming them, and all that good stuff. Same thing here. Uh, so the reciprocal mother function is f of x equals 1 over x. So what that looks like is this. You've got your basic points here. The most important ones are 1, 1, negative 1, negative 1. And also, if you can follow your asymptotes, you don't really have to worry too much about the other points. You will have an asymptote at y equals 0 and x equals 0. And of course, whenever you do shifts, those will move. So these should be dotted lines, but I'll make them red, pretend they're dotted. I can take 2 seconds and make them dotted, I guess. So remember, the asymptote is that imaginary dotted line you can't really cross. So that'll work on that one. And just your graphic approaches that line, gets closer and closer into it, but never really touches it or crosses it. We'll represent that with a dotted line. So now the key points are the 1, 1, negative 1, negative 1. We also have these other points that make it a little easier for us to sketch the graph. So at a half, we have y equals 2. At 2, we have y equals a half. And the negatives are also true. Negative 2 is negative a half. Negative a half is negative 2. And we're just going to sketch this. These are going to be very, very, Let's do the best you can. So look something like that. In that section. And try to just approach that asymptote. Try not to cross it. That's about what it looks like. Now, the name of this kind of graph is a hyperbola. It's one of those conic sections. You're used to feeling for parabola. This is another conic section, the hyperbola. Now, for the domain and the range, we have to watch our asymptotes. The domain in this one is broken up by this vertical asymptote here. So we cannot include 0. So we write that. Negative infinity, I'll go ahead and use this way. Negative infinity is 0. Union 0 to infinity. So I wanted to get this lesson because it's good practice for you to remember how to do interval notation. Remember, parentheses do not include union to join two different sets. And for this particular problem, the range is also the exact same thing. It goes down forever and up forever, except we can't have this 0 here. So negative infinity to 0, union 0 to infinity. Now the equations of our asymptotes are what we're looking for, not just a number, but the actual equation. We have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 0. That's the sort of thing I'm looking for. In the standard form, we will be transforming these. So here's the standard form. The a term on top, x minus h plus k. K is the vertical shift, h is the horizontal shift, the opposite sign. And a determines, the stretch of compression vertically and whether or not we're reflected over the x-axis. So again, h is the horizontal shift, k is the vertical. And remember, Vertical is what you think it is. Plus is up, minus is down. And as always, that x is just backwards. Plus is left, and minus is right. So again, A reflects it across the x-axis. It should be, familiar to you. It's the same thing. If we have a negative out front in front of the function, that's going to reflect over the x-axis, regardless of what kind of function it is. If A is a big number, bigger than 1, that's going to be a stretch. Stretch. And if it's a fraction less than 1, it would be a compression. Just look at the absolute value there. Negatives would be considered reflection or no reflection. So between 0 and 1, that's a compression. Bigger than 1, it is a stretch. If it's negative out here, it's going to reflect over the x-axis. The vertical asymptote, that's always going to be x equals something. It's going to be x equals whatever h is. And if you think about it, that's what would make our denominator 0. That's how we get our vertical asymptotes. We let our denominator be 0. So that's any kind of vertical asymptote. We'll be dealing with rational functions later, and that's how we'll find the vertical asymptotes. Horizontal asymptote is y equals k. That's your vertical shift. That's what's going to move that horizontal asymptote up and down. So let's just take some words and write down what those functions would be, and let me get my face out of the way. The reciprocal parent function is reflected across the x-axis. That means you have a negative out top. Then translated 4 units to the right, 3 units down. So that's going to be a negative 1. I didn't say we were stretching or compressing it. 4 units to the right. So that's going to be x minus 4. 3 units down, minus 3. So that's what your function would look like. I'm going to use f of x. You could use y. It'll probably be easier if you just use y in the assignments. It'll be quicker and easier to type. If you want to use f of x, that's more proper. Either way is perfectly fine by me. Let's see, we're stretched by a factor of 2, so that makes a 2. Translated 7 up, so plus 7 out here, and 1 unit left. So x plus 1. So again, you can just use y. I'll take it. Number 3, we have a vertical asymptote at x equals negative 2. So that means if we plug negative 2 in down here, we're going to get a 0. And a horizontal asymptote located at y equals 5. So that's telling us our shifts. It says write an equation that could represent this function. It didn't tell us anything about stretches or compressions or reflections. So this a term could be anything. I'll just leave it as 1. And I'm going to put x plus 2. Y plus 2. Well, remember, h is our vertical asymptote, and it's minus h here. Minus 2 is a positive 2. And a plus 5 there. This is one possibility. This count number could be anything, positive or negative. It could be even pi if you want it. Doesn't matter. As long as it satisfies these two conditions, which this satisfies this condition, right here satisfies this condition. Good to go. So let me show you how you're going to be graphing these things, because obviously you're not going to write it on paper and email it to me or anything. So I've assigned you, well, I will be assigning you a Google slide. Here's what it's going to look like. We can open this up. It's going to have a name. It's not going to be untitled. And this is what it's going to look like. It says graph each function, identify domain range, and asymptotes. So it's got this right here you can't edit, but you can edit these dots. That's what you're going to do. You're going to drag and drop these dots. So I'm going to start just by putting my basic points, and then I'm going to transform them. If you already know where the points are going to go at the end, you don't have to do this extra step. But to practice transformations, it might help. Now, if you just use your arrow keys, it's going to jump a lot. If you hold shift while moving your arrow keys, it makes it easy to get it right where you want it. And of course, these do not have to be perfect. Oops. So you can drag and drop the dots. That's not all you're going to do, though. I don't know if I can count. Sorry, it's a little late. And there we go. If you remember, those are our basic points. And we look at what this graph is doing. We're not reflecting. We're not stretching or shifting it horizontally. No stretches or compressions. We're just moving it all down 2 units. I'm going to highlight them all, and let's see if this works. Yeah. That moves it down 1. There we go. I move them all down 2 units. So for your shifts, you can highlight them all at once, just grab them like that, and it'll move them all at once for you. Or you can just plot them where they go to begin with. Your choice. All right. So now you actually need to draw the graph. So you're going to come up here, and you see these shapes and these lines. Let's start with our asymptotes. So I'm going to draw a line. My vertical asymptote didn't move because I didn't have a horizontal shift. So I'm going to do it just like this. And if you do this, it's wiggly. But if you hold shift down, it'll make it nice and straight for you. And then let's change the color to red. I think I changed that color. It's too thin. I don't like that. So you can make it thicker. 12. 12 sounds good. Okay, that's too thick. 4. Sure. Just make it so that, we can actually see your asymptote. Holding shift down again, and there's where my asymptote would originally be. I'll do light blue for this one. But we went down 2 units, so 1, 2. You could again draw your asymptotes before shifting, but then they might go off the grid, and that really doesn't matter, but up to you. Got our asymptotes. We've got our points. All that's left is actually scribble the graph. That's exactly what we're going to do. We're going to scribble. So right here, go to this drop-down menu and click scribble. Now, I'm not quite sure how well this is going to work. Because, yeah, there's that one. And then I need another one. This way. Whoa, that didn't work. I might have to do this all in one stroke. Terrible. So yeah, it's not the easiest thing to do, but it's there. And please do make it a little thicker for us so we can see where you're going with these. So I'd really like, hey, move that up a little bit. That's better. And then of course we have this one. Maybe I can do it all at once. But now I'm not going to be able to draw this arrow, am I? Okay. That'll work. I'll make it a little thicker. Good enough for me. So that's how you're going to draw your graphs. Not the most convenient way, but we gotta do what we gotta do, people. So now the domain. Well, it's everything but 0. So here's a text box. Use it. Click on the text box, make it a little big. Now you're gonna open up your parentheses, and you need negative infinity. Well, you're gonna insert, and then we gotta go down to special characters. And then just kind of in this place right here, you can draw your symbol. The infinity looks like this. There it is. I guess that looks like a fish too to some people. So click that. I think I clicked it twice. I did. Negative infinity to 0. And you can just use U for union. 0 to infinity. And here's a trick. Control C or Command C, or I don't know about Chromebooks, but Control C for Windows computers, Command C for Mac computers will get you to copy that. And you can do the same thing over here. Negative infinity. Excuse me. But if we look at this one, we went down 2 units. That's my horizontal asymptote right there. And that's what breaks my range up. And so after I inserted the infinity ones, I'm just Command V or Control V to get that back. It's already copied it. Okay. Vertical asymptote, x equals 0. It's going to automatically capitalize the x for you. Don't worry about that. It's fine. Horizontal asymptote, y equals -2. And then that's done. So yeah, let's just practice a couple of those so you can see how it's done. I'm not going to give you, well, yes, I'm going to give you quite a few of these. But you'll be all right. Just kidding. I'm only going to give you 20 or 30 or 15. So after you kind of understand how to do it, you can just use these 2 points here. I'll be okay with that. I'm sure Mr. Doyle will be too. If you want to, you can plot all 6 points, but really, these right here are the 2 main ones. If you have these and you have your asymptotes, you pretty much have your graph. I mean, I don't think I even touched my points on my previous one, did I? Yeah, I kind of went through them. I actually did not too terrible. You can save time just by plotting those, because you also have to transform them. But hey, if you want to, go for it. We got this one over here. We got this one over here. And something like that. I'll just do the 1 dot each on the next one, so you can see how that would look. Okay, about like that. Points a little off, doesn't have to be perfect. So let's see what's going on. Negative, that's going to reflect it over the x-axis. I don't think there's a shortcut for that. Let's reflect over the x-axis. Let's see. Nah, there's no reflection button. So this one's going to go right here. This one's going to go right here. This one's going to go right here. This one's going to go up here. It's going to go up here. And this is going to go up here. I'll move these a little bit, try to make it a little neater. Okay, I did the reflection. I also need to shift them up 3, right 5. Up 3. I'm going to watch this dot right here. It's easier to see. 1, 2, 3. And then to the right 5. I'm still watching this dot. 1, 2, 3, 4, 5. And there we go. That's good enough. That works. Now the asymptotes. And I'd probably say go ahead and draw them after you should do all the flipping and shifting and whatnot, because they would go everywhere. So I'm going to select the line again. And it's going right here. Hold down command, shift so it doesn't go everywhere. And I'll do another one. This one is at 3. 3 and -5, or 3 and 5 are my asymptotes. X equals 5, y equals 3. And let me change those colors because it's really hard to see. There we go, now we can see. So there's my dots, there's my asymptotes. Let me scribble now. I'm going to try and go all at once. Let's see how I can do this. That's not too terrible. That's a purple color. Oh, okay, still we'll see. Blue. All right. And if you just saw that, you can actually make these dotted. It's nice. I'll make that different colors. Let's do C2. Yeah, it's even better. So scribble again. And there we go. There's my graph. So my domain is everything but this right here, 5. So oops, back to my text box. So negative infinity, it's still on there from last time I copied it, to 5, union 5 to, and I'll show you again how to get there. You go to insert symbol, special character writer, and you draw it, and there it is. The range, negative infinity to 3. And my vertical asymptote, x equals 5. And my horizontal asymptote, y equals 3. And that's it. So there's the graph, domain and range. And I guess I could go back and change these to dotted. Let's do this last one, sorry, bugs. Okay. So this one I'm actually going to need all dots. Great. So I was going to just do the one dots, but for this whole, ooh, I want to do that. Command Z or Control Z undoes things, by the way, so that's very useful. So yeah, we need all 6 dots because of stretches. Dang it. I doubt it's going to look much different for me because I'm terrible at drawing. Yeah, it looks pretty terrible. Now, the first thing I see is I have to double the y values. Oh, you know what? I'm going to do with one dot. Forget that. If we double the y values, this will be up here. That'll be down there. I'll give you a hint. 1 times 2, that's 2. Negative 1 times 2, that's negative 2. That's all we're doing is we're doubling the y values. And if we do that, I will be able to see that you did double them because they'll be in the right spot. If you really wanted to, this would be at 4, 3, 4. And this one would be at, that's a good idea, 1. So I'll do the top part with all 3 dots. The bottom part was just 1. You'll see that there's really not much of a difference for my drawings. So I doubled the y value here, I got 4, I doubled the y value here, which was a half, it's now 2. So I'm going to draw my asymptotes, negative 4 for my let me shift first. Left 4, I'm going to watch this time. 1, 2, 4, something like that. And down 7. I'll watch this dot because that sounds nice. 1, 2, 3, 4, 5, 6, 7. I'm just using my arrow keys to move those. It's a heck of a lot easier than trying to drag it around. Now I'm going to draw my asymptotes. Line again. And it's going to go right here at negative 4 on the x. And hold my shift button down, makes it a little easier. I'll make it red, 4 points, and dashed. Other one at negative 7, so that's 3, 6, 7, right here. Oh, got 7. Nice. And now I'm going to scribble my line. So yeah, this is going to be tough because it's off the thing. I need that arrow down there, but I don't think I can hit it. It's going to touch the other side. Oh, yeah, got it. That'll work. Yeah, this one's going to look something like this. And you know, you can, if you want these to be yellow or red or whatever, just make sure we can see it. That gray is just so hard to see. And then we need a domain, range, vertical, and horizontal asymptotes. I'll probably write that after this video. Connection law. Oh, today. Domain, negative infinity to domain. Let's look at it. All right, here's my vertical asymptote at -4. That's where it breaks up at. All right, the range breaks up at -7. Vertical asymptote. X equals -4. Horizontal asymptote. Y equals -7. And then lastly, a couple more of these guys. So we're going to transform the basic mother function. Reflecting across the x-axis, that's going to make it negative. So I'll put a -1. I'll click out of there. And on the bottom, I'll put my x. I don't have any horizontal shifts, so I'm just going to leave x. They're nice close to each other. A little line underneath them. Don't want you to connect there. Where you go? Oh, that's weird. I don't want you. No lines. I'm sorry. I have no idea. Go ahead. I just have to make it a really big line for some reason. I don't know what that's all about, but whatever. Sure. Good enough. Don't spend 20 minutes trying to draw a line like I'm doing right now. That's good enough. -1 over x, and then translated 5 units up. So that's going to be +5. Something like that will work. Vertically stretched by a factor of 2. So then you put a 2 on top. Reflect across the x-axis, that's a -2. Let's make the box a little bigger if that happens. Let's see if I enter. And then translated 1 unit left, so x +1. Actually, 8 units up. +8. And try and draw a line there. What's going on with these crazy dots? Maybe scribble would be easier. Yeah, those disappeared. Why did they disappear? There. Good enough. -2 over x +1 +8. Okay, I put one of those in there. That's annoying. And that's all your works and beyond for the first assignment. If you have any questions, post them in the stream, and I'll see you next time.